Hello, how do we solve this nice algebra problem? D times D times D could be written as D to the power of 3 minus D times D could be written as D square equal to 100 also could be written as 125 minus 25. D to the power of 3 minus D square is equal to 125 is the same thing as writing 5 to the power of 3 minus. Also, I can rewrite 25 as 5 square. D to the power of 3 minus D to the power of 2. Now, let's move each of this guy to the left hand side. So that will be minus 5 to the power of 3 plus 5 square equal to 0. Let's continue. This implies that. Let us rearrange this equation. Doing that, we have D to the power of 3 minus 5 to the power of 3 minus D square plus 5 square equal to 0. I can put these two guys in brackets. So I have D to the power of 3 minus 5 cube. Also, to put these two guys in brackets, we need to factor out the negative sign. So that will be minus into D square minus 5 square equal to 0. Let's continue. Recall that A to the power of 3 minus B to the power of 3 is equal to A minus B times A square plus AB plus B square. Take note of this identity. Applying this identity to this guy, we have D minus 5 times D square plus 5D plus 25 minus D square minus 5 square is the difference of 2 square. We can rewrite it as D minus 5 times D plus 5 equal to 0. Let's continue. You will notice that D minus 5 is common. We can pull it out. So we have D minus 5 into D square plus 5D plus 25 minus D plus 5 equal to 0. D minus 5 times, let's drop this bracket, we have D square plus 5D plus 25 minus times D minus D minus times 5 minus 5 equal to 0. Let's continue. D minus 5 times, let us add the common terms. We have D square, 5D minus D, that is 4D, 25 minus 5, that is plus 20, equal to 0. This implies that D minus 5 is equal to 0, or D square plus 4D plus 20 is equal to 0. From this line, D is equal to 5. This is the real solution. Now, let's consider this quadratic equation. You will see that it is not factorizable. So, we are going to solve it using quadratic formula, which is D equal to minus B plus or minus square root of B square minus 4AC divided by 2A. From this equation, A is equal to 1, B equal to 4, and C equal to 20. D equal to minus, what is B? B is 4, plus or minus square root of B square, that will be 4 square minus 4 into, what is A? A is 1, into, what is C? C is 20, divided by 2. What is A? A is equals to 1. Let's continue. D equal to minus 4 plus or minus square root of 4 square is 4 times 4, 16, minus 4 times 1, 4. 4 times 20, 80. Divided by 2 times 1, 2. Let's continue. D equal to minus 4 plus or minus square root of 16 minus 80. That is minus 64 divided by 2. D equal to minus 4 plus or minus square root of minus 64 could be written as square root of 64 times square root of negative 1 divided by 2. D equal to minus 4 plus or minus. What is square root of 64? That is 8. And what is square root of minus 1 from the complex number? Square root of minus 1 is equal to I. So we have I here divided by 2. D equal to, from this numerator, we can factor out 2. So that will be 2 into minus 2 plus or minus 4i divided by 2. D equal to, clearly, 2 cancels 2. We have minus 2 plus or minus 4i. Therefore, all the solutions that we have for this algebra problem are D equal to 5. This is the first solution. Let's call it D1. D equal to, considering this positive sign, we have minus 2 plus 4i. Let's call this D2. And D equal to, considering the negative sign, we have minus 2 minus 4i. Let's call this D3. You will see that in total, we have 3 distinct solutions, 1 real solution and 2 complex solutions. That's it. Thanks for watching.